In the long run, the probability of success is determined by the belief in ourselves. Hello all, welcome to this new video. I hope you all are doing well in your life. In today's video, we are going to learn three types of probability distributions. First one is uniform, second one is normal, and third one is approximation of normal distribution. Alright, so the first one is normal distribution. The first one is uniform distribution. Okay, so let's understand the concept with the help of a rectangle. Okay, let's say assume that the area, this complete area is 1. Alright, and this is determined by breadth or length, and this is your height in the rectangle. So we know that area is equals to b into h, which is breadth into height. So in this case we know that our area is 1 and we don't know the breadth and height, so we will make an equation as height is equals to 1 upon breadth. Okay, so whenever we have to assume the height or put the height in our area, we will put our height as area is equals to b into 1 upon b. Okay, so why I taught you about the area and all, you will understand. So let's understand the actual uniform distribution concept. Okay, let's take an example that consider the random variable x representing the flight time of an aeroplane. Suppose the flight time can be any value in the interval from 120 minutes to 140 minutes. The random variable x can assume any value in that interval. So in this scenario, in this case, the flight time is given and the x lies in between 120 to 140. So x is our random variable. Okay, now if we convert this into probability, the equation will become like this: 120 less than equals to x lesser than equals to 140. Okay, so to visualize this probability, we can draw an uniform distribution diagram. Okay, so whenever the word uniform comes up, you will have to remember that the probability is spread uniformly in the axis. This is our x and y axis and this is our probability. So the random variable x somewhere lies in this diagram and our timings are given as 120 to 140, and this is our uniformly spreaded probability. Alright, okay, so this is our equation in the uniform probability distribution diagram. So always remember that whenever we make an equation, the area is always 1. Okay, So if we convert this into percent, this is 100%. Alright, now we have to, as I told you just now, that area of a rectangle is equals to B into H. So in this case also, area is going to be same as 1, and B is going to be 140 minus 120. How I calculated? The help of this. And we don't know the H, the height. Okay, so we know that H will be 1 upon 20, and that's it. We have calculated the height. Alright, so let's take an example. There is a situation in which it is asking us what is the probability that the flight time is between 120 and 130 minutes. Okay, let's understand this with the help of a diagram. So our situation remains the same. We have the actual flight interval as flight interval time between 120 and 140. Okay, and now the situation is asking us what is the probability that the flight time is between 120 and 130. Okay, so whenever they will ask you the probability, you will have to make equations like this: probability into bracket 120 and the random variable x lesser than equal to 130. This is how it is asking us. Alright, so we know 120 lies here, and 120 plus 10 is going to be 130, which is in the middle. So the situation is asking us about this much amount of probability, this portion only, the shaded portion. So with the help of diagram, we can see that this portion is half of the overall portion. So as I told you previously, the area is always 1, and half of this is nothing but 0.5. So we got the answer by visualizing the diagram. But in the case of an equation, how we gonna do that? So area is equals to, we know B into H, and we know that area is always 1, and in this case B, what is B? We are finding the area now. We are not finding the height, as we already know the height. So in this case B is going to be 130 minus 120 into 1 upon 20. So this will give us the area, because we have to calculate the probability. So probability means this area. So if you will calculate this is going to come around 110 by 20, which is 1 by 2, which is 0.5. So area is equals to 0.5, half of it. Alright, I hope you understood this. This was a very simple concept. Always remember that whenever they ask you about uniform probability distribution, you will solve the concept with the help of a rectangle. Okay, first they will give you the situation. Depending upon the situation, you will craft a random variable in that diagram, and then after giving the situation, they will give you some cases. They will ask you to calculate some probabilities depending upon those cases, and once you calculate the height, you will be able to calculate the probability as well. So that's it. Now in the case of uniform probability distribution, we must know that we also have to calculate mean and variance. Alright, so mean is denoted by E into bracket x, which the formula is a plus b by 2. Similarly, variance is denoted by var x, which has a formula as p minus a whole square divided by 12. Now, our previous situation was the probability between 120, which is lesser than equal to x, which is lesser than equals to 140. So according to this case, our a is going to be 120. Alright. So our a is going to be 120, b is going to be 140, and to find out the mean is going to be e into x, 120 plus 140 by 2 equals to 130. Okay. Similarly, variance, which is var x is going to be 140 minus 120 whole square by 12, 33.33. I hope you have understood the concept of uniform probability distribution. If you have any doubts regarding this concept, ask me below in the comment section. Okay, so till now we understood what is uniform probability distribution. So let's dive deeper into the same concept, and let's take some example. So first example, the question is asking us the random variable x is known to be uniformly distributed between 1.0 and 1.5. So first, question A is asking us to show the graph of probability density function. So the graph is going to be like this: y-axis, x-axis, and the random variable x is between 1 and 1.5. Random variable x is uniformly distributed between 1 and 1.5. So in this case, the area is equals to probability is always 1, as I told you. So what we do is, step 1 is to make the graph. Step 1 is to show the graph. And plot the uniform distribution. Step 2 is to calculate the height in the same situation. So our step 2 is going to be area is equals to p into h. We know that, we have seen earlier. This is our p, breadth, or you can say length. And in the case of UDL, area is always 1, b is going to be 0.5, 1.5 minus 1.0 into h, which we have to find out. So h is going to be 1 upon 0.5. Okay. Now, okay, so this is our 1 upon 0.5. Alright. Now, question B is asking us to compute probability, which is x equals to 1.25. Okay. Okay, so question B is asking us the probability of x, which is equals to 1.25. So let's understand this question with the help of a diagram. We know we have our situation uniformly distributed between 1 and 1.5, and here somewhere lies our 1.25. So probability at this point x is what? So probability, always remember, probability at any point is always 0, because it is asking us on a point. It is not asking us between the variables, it is asking us on a point. That is why it is going to be 0. Alright, next. Okay, so question C is asking us to compute the probability which is between 1.0 less than equals to x less than equals to 1.25, meaning that the x, what is the probability of x which lies between 1.0 and 1.25. So let's make the diagram. This is our 1.0, this is our 1.5, and here in between both is our 1.25. The x lies between 1.0 and 1.25. So the question is asking us this much amount of portion. Question mark. So to calculate this portion, we have to calculate the area. Area is our probability. So P into H is our area. So area equals to B. B is going to be 1.25 minus 1.0 into H we have calculated as 1 upon 0.5. Alright, H is equals to 1 upon 0.5 previously calculated. So our area is going to be the area is going to be 0.5. By the help of visualization, we can also see or sense that this is how much the distance it is, 0.25 half, and this is also 0.25 half. So the probability, if the probability is asked in the half distance, it is always and always going to be 0.5. Okay, let's move to next question. So next question D is asking us to compute the probability between 1.20 less than x less than 1.5. New case. Alright, let's understand this with the help of a diagram. Always make the diagram, always have the habit of making a diagram. Alright, so our case is uniform distribution between 1 and 1.5, but in this question we have given as 1.20 and 1.5. so our random variable x lies in here, and we cannot visualize or calculate simply with the help of understanding the diagram. So in such scenarios we have to actually calculate the area. So area is going to be P into H, 1.5 minus 1.20, highest minus smallest, into 1 upon 0.5. The area is going to be 0.60. Easy? I hope you must have understood this. In the book, the concept is explained with the help of a function, uniform probability density function. Both are similar, but in my case, I taught you the whole concept with the help of area. You can use this. This is a very simple method. It is very simple to understand. It gives you a clarity in understanding the whole uniform distribution concept. Okay, let's take some business case example. Right, here is the situation. Tesla, as you all know, the electric autopilot car manufacturer. So Tesla battery recharge time. The electric vehicle manufacturing company Tesla estimates that a driver who computes 50 miles per day in a Model S will require a nightly charge time of around 1 hour and 45 minutes, which is equals to 105 minutes to recharge the vehicle's battery, claimed by Tesla company's website. Assume that the actual recharging time required is uniformly distributed. Tesla battery recharge time, the electric. Oh my god. Assume that the actual recharging time required is uniformly distributed between 90 and 120 minutes. Okay. So the question A is asking us, give a mathematical expression for the probability density function of battery recharging time for this scenario. All right, let's solve this. So as I told you, when the situation is asking us, you have to always make an uniformly distributed diagram. So in this scenario, our uniformly distributed time is between 90 and 120 minutes. So 90 and 120 minutes. So random variable x lies in this portion, right? So our mathematical expression is going to be probability, random variable x lies in between 90 and 120. Alright, function of x. Now the other thing which we do immediately is to calculate the height. Alright, so we know in this case area is going to be b into h, as always. Area is 1, b, which is going to be 120 minus 90 into height. So height is equals to 1 upon 30. Okay, so our height is 1 by 30. I hope you got a clear understanding. So question A has been solved. Question B is asking us to do what is the probability that the recharge time will be less than 110 minutes. So 90, here lies the 100, and somewhere here lies the 110. So lesser than this means the probability is asking us this much portion. So the probability is going to be x, which is less than 110. Alright, so probability means area is going to be 110 minus 90 into 1 by 30. Okay, So area is, so the probability of x means recharge time, x is our recharge time, is going to be okay. Let's so B has also solved. Let's move to the next question. So C is asking us what is the probability that the recharge time required is at least 100 minutes. Okay, let's understand the terminology of probability first. Whenever in probability, if the question is asking you to compute at least, it means that greater than x. Okay, and when it is asking you to calculate at most, it means less than x. Okay, so if someone asks you at least one, it means that 1 and greater than 1. Alright, and whenever someone asks you at most 1, it means that 1 and less than 1. I hope you got an understanding. Whenever the situation will come, I'll tell you in detail about it, but right now just understand this thing. Okay, let's move to the question. What is the probability that the recharge time is at least 100 minutes? So the uniform distribution is between 90 and 120, and here somewhere lies the 100. Okay, so as I told you earlier, at least means consideration of that same variable and greater of that. So it is asking us this much portion. If we have to make an equation, we can make it like this. This is our equation. Probability of 100, which is less than equals to x, less than equals to 120. Okay, this portion is our x, which is our probability, which is our area. To calculate it, we know 120 minus 100 B into H formula, and this is going to be 1 by 30. So 20 divided by 30 is going to be 0.67. So C is solved. Let's move on to the next. D is asking us to compute the probability between 95 and 110 minutes. This is 90, this is 120. This is a tricky question, a different question asked in a very different way. So the probability portion is asking us between 95 and 110. This much portion. Okay. Alright. We know area is equals to B into H. So probability between 95 less than X, 110. So B is going to be our 110 minus 95 into 1 by 30, and the area is 0.5. Alright, so the portion between this interval is 0.5.